Hey, howdy. So, I've got a bit of a fun experiment for today. So, recently, in my own time, I created this simple little game in Desmos. Now, Desmos is a graphing calculator, and it is not designed for games, but I made it work. I'm going to show off the game here, and then I'm going to break out into another graph, and I'm going to try and recreate it. I'm going to try and make a basic maze game with this little controller right here, where you work to get the frog out of the maze. Or you try and get it to the other end of the maze. Like so. It's sort of a double-edged sword in a way, because on one hand it feels extremely simple, but on the other hand it seems extremely complex because I'm making a game inside of a graphing calculator. But let's go through it one step at a time so it's a little bit easier to process. Also, I copied over the ASCII stuff, so I don't have to Google it. I can just grab it from there. Okay, so what exactly do we need for this? Let's write it all down first. So we need the frog. And for the frog, we're going to need a point. We're going to need logic for movement. And the label already covers the sprite. So that's good. For the, oops. We need the controls. All right, I'll call it the control panel because that's what I called it over on the other thing. It needs to be clickable. I need to be able to modify the frog position. And I need to be able to check for walls. And on that subject, I need a grid of walls. I need to be able to render them. I need to be able to store them. And for the sake of my own sanity and not having to type it all out manually, I need a way to add and remove from that list. And then I need I'll call it the victory condition, that little green block. I need a way to render that. And I need a game over state, let's say. Okay. So now that we have all of those, let's start constructing our world. Let's put the frog, let's have it start in position 11, comma 3. So frog equals 11, comma 3. And then I'll do some quick work here. Make it undraggable, and replace this label with our little frog. And that looks the same as it does over there. And it's the point is black over there too, so that works. Okay. Next, we need the grid, and I think what I'm going to do. Yeah. Maybe I'll come to regret this later, but let me just make a folder called frog, and for the time being, let's put the frog in there. And I'll put stuff related to the frog in here as well. And then let's make another folder for the grid. And then let's just make a variable called grid. And for the time being, let's have it only have one value at, let's say, 6, comma 2. And then I'm going to need two functions. I need grid add. Yeah, there's not really a better way to do that. Grid add. And I'm going to need grid remove. Now, grid remove, I'll put in grid remove I in particular. And for grid add, I'll need a point P for what ends up getting added. But how do I decide what grid add adds? For that, I'm going to need, let me just break this out into another folder. I'll call it edit grid. and then I'll need a point P. Edit P equals 5, 5. This one actually is draggable. But I'm getting a little ahead of myself. First, let's hide this and let's try and render these grid spots. So the way that I did it over there is I need to use list comprehension here, which is a little messy, but I can make it a little less messy by just doing g equals grid. I don't have to worry about the grid elements as much, but I still have to worry about them a little bit. And then I'll do g plus something like this. And I'll pull this out so that it's easier to see. I'll pull it back in a second. And there we go. And then let's make it black for the time being. Okay, I want to test something. Let me just make a opacity. Because I had this big function back here. If I go and check grid, oops, it's this one. I had this huge function in here. I want to try and see if I can just use something like this and then just plug in opacity. But the logic is the same otherwise. Pos.x minus grid.x. All that squared plus, oh, not pos, frog. Frog.x minus grid.x squared. And then same thing, but y. And then all that square root. And then for the polygons, this is equal to opacity. This is equal to opacity times 0.4. What am I missing? Hang on. Ah, 4 minus, right. Missing a crucial step here. Because let's make the frog draggable for a second. I want to have the effect where as you approach, they become more visible. And then as you back away, they become less visible. And then let's add that thing that I had earlier, where this is opacity times 0.4. So it has that effect that it normally has. Okay, so that's done. What I also want to do is let's add a control panel here. Let's have it be right here. And you might have noticed that there was a piecewise expression in there with a variable. Let's add in that variable. Let's add Fulbright equals 0 from 0 to 1, step 0, or step 1. And then while that is set to 1, we can just ignore this logic entirely and just make it so that the value is equal to 1. So let's add that in. We need brackets here. Fulbright equals 0 colon that or 1. That will be more apparent as I add more squares. So now that I have that, let's see. For edit grid, let's add edit square equals edit p I need another polygon with p equals edit p, let's go with something like this. Edit p.x, rounded, edit p.y rounded. And then let's just copy over this stuff from over here, and then swap out G for P. And then now I can make this clickable. Oop, wait, I actually can't make this clickable yet because I need to remind Desmos that this kind of stuff actually does exist. Okay, now I should be able to. Clickable, there we go. And now that something has an action in the scene, it shouldn't have any other issues. Let's make both of these black so that it all lines up, and I'll make this 0.5, I'll make this 0.2. And then what I can do now, I'll do grid add, that takes a variable. The variable will be edit p. Can I do grid add p? Does it let me do that? No, it doesn't. Because I can just copy this in. Oh, right. Grid add is not an action yet. Forgot about that. So let's make it an action. Grid is over here. Grid becomes the join grid with something else. And it should be as simple as add p like that. So I'll save this as frog in maze 2. And there we go. This allows me to edit the maze a lot more easily. And these kind of peripherals, like you never really think about them when you're making stuff, like you're making games or you're making music. It really does help a lot to be able to do this. And I am not good at designing mazes on the fly, but I'm going to try my best. That should be good for now. And just to prove that it works, let's turn off Fulbright for a second. And let's turn off those grid lines. And now, as I move around the maze, it has that that effect looks awesome, at least in my opinion. Okay, so we have that. We have a way to add. Let's turn Fulbright back on just for the sake of clarity. I'm also going to add the ability to remove stuff from the grid, which, just because it would be a pain in the butt otherwise. And the way to do this is a little bit more tricky. Does it let me do this at all? Yeah, it does. Good. Sometimes it freaks out if you have multiple things, multiple actions modifying the same thing, but because these will be bound to different objects, it shouldn't matter. Grid, instead of being just join grid with something, we want it to be two distinct lists. Both of them will use list comprehension. I+1 ... length of grid. Now this breaks sometimes, but for our purposes, this works. And then I just use grid I. Oh, n, right. Forgot. I was using I as the index there. Grid n, grid n. Okay. And now save that. And then if I go to this polygon, clickable, remove, grid remove, index. And now if I did this right, let's save just in case. Yes, awesome. Now whenever I click things, they get removed. So now I can just edit things at my leisure. And then let's also add in a variable in the control panel for edit mode. And then for the edit stuff, let's do something like this. Edit mode equals 1. They show up. Oops. Should be over here. There we go. Yeah, and the square also hides itself, so that works. They appear, they disappear. So that all works. Now I think it's time for us to add in the way that you move. And this is where things get a little bit tricky, but again, like if we take it one step at a time, it will be fine. Let's take these two functions and move them into grid for the sake of clarity. And let's make a new folder for controls. And from here, let's define a point d-pad equals, let's go with 15, 1. Let's like drag it around. That spot should be good. And then I can just copy this 1, 2, 3, 4. I mean, hell, this is probably what I should be doing is let me just make this function move x, and I won't define it for now. Or I'll define it, but it'll be very basic. In fact, it'll do nothing. But bing. But I'll make it purple, oriented up, or I suppose let's do by rotation. So it starts on the right, and the label is also that direction. And it has a size of 2. And then we can go into settings and just copy this. 2, 3, 4. Oop, there we go. And then left, and then down. So now, oh, I should have, that's stupid. Okay, whatever, we can add it manually. If I do move 1, and then this will be move 2, and this will be move 3, and this will be move 4. Okay, so now comes the tricky part. So right out of the gate, what I can do is I can replace this 0, 0 with an array immediately followed by a index. This is weird syntax, but Desmos lets you do it, and honestly, I'm fine with it. Put the x in there, and then there are 4 different points that we could potentially add. Starting from the one on the right and moving in a circle, it could be 1, 0, 0, 1, negative 1, 0, 0, negative 1. And the frog moves! It's alive! And it looks like it works really well until that happens. So we need to deal with the collision. And, oh, wait. Before I do anything, Where are you? It would be in grid. Let me go ahead and add edit mode equals 1 or grid. Yeah, so now you can click on, well, God, let me try just removing that condition. No. Maybe if I attach this to the clickable aspect? Let's see. Okay, now it runs perfectly fine again. If I add this over here, it's going to be a little ugly, but you know, I'm working in Desmos here. I'm happy it works at all. Okay, that works. Now it doesn't do anything unless edit mode is 1. Okay. So we make that purple so that it actually works, and I can, because this is a draggable point, I can drag this wherever I want. Now let's deal with the elephant in the room. Let's deal with the collision. So I'm going to need a helper function here. And I think the best way to do this is let's make a function called collides, p. And let's do the same thing we did before with p equals that. Does it freak out? No, it doesn't freak out. Good. So for G in the grid, we need to check whether it doesn't collide with anything. So the best way to do this, I've found, is to use a piecewise expression in a list like this, and then check whether that value is equal to 0 or is greater than 0. So what we're going to do is we're going to do two different things equals equals 1, 1 comma 0. Okay. P dot x equals G dot x, 1 colon 1 0, and then P dot y equals G dot y colon 1 comma 0. And I mean, hell, everything inside of this is defined, so I could just get rid of these entirely. So now this function right here, this is essentially an AND statement. It will return a 1 if and only if both the x-coordinate and the y-coordinate of P and G match. Otherwise, it will return 0. And then what I can do from there is get the total value of this. And then just to keep it neat and tidy, I'll surround this by another piecewise expression. And then, let's see, greater than or equal to 1, 1, 0. So I've clamped it between 1 and 0. And then, let's see. Collides with P equals 0 colon. Okay. Save. Does it work? It does. Oh my god. I was not expecting that to work on the first try. I was expecting to have to fiddle with it a bit. If you notice, it's not even indicating that I'm hovering over it anymore. The clickable aspect is being completely disabled when I'm right up against a wall like that. That's perfect. Okay. Before I add the exit condition, let's add some sound. And to do that, it's more complicated than you might think, because Desmos does have support for sound, but it's weird. Let's make a new folder for sound. And I think the best way to do this is I'm going to need a driver function. So let's make another thing for this. Driver function. So what is a driver function? Well, a driver function is a neat and tidy way to, hang on, let me just do a equals 1, a action a plus 1. Now that I have actions enabled, I can add a ticker which will trigger automatically every however many milliseconds, and it defaults to 0, so it will just go every frame that it possibly can. And if I chuck in the driver here and let it run, every single frame it will update this. Now, this is not really what I care about. Instead, what I'm going to do is let's change this a little bit. I'll come back to the driver in a moment. Desmos has a built-in functionality for making audio, but it's a little strange. It's based on raw frequency, so it becomes 440 and then whatever volume. And you notice that this came up. It's unmuted by default if I were to unmute. It's muted by default if I were to unmute it. We get that medium volume tone at middle C. And if I were to make this double the frequency at 880, it's 1 octave up from middle C. So the way that this works is kind of a weird formula. It's something like that. And if I were to change this number, it will walk up the scale. In chromatic, of course. And even worse with negatives. Anyway. Let's take this tone and let's move it over into sound, because that's where it really matters. And let's make 2 variables. Because if I let this go, it's just going to go on forever. So let's make 2 variables. Let's make pulse and let's make pitch. Pitch, we'll keep it 0 for now. Pulse, let's just, for the sake of clarity, let's have it span from 0 to 30. And then pulse over 30. I might change this depending on if it's super grating, but for the time being, I'm fine with it. And then it will be pitch over 12. And for the sake of clarity, again, this isn't going to affect anything, but just for the sake of it. We now have the ability to generate whatever sound we want, as long as it's a single frequency. So how do we use this? And why did I bother making the driver? Well, what I can do is, let's have the pulse max, rather, of pulse -1 and 0. So now, if I start the driver, it will immediately fall back down, and it'll create that nice sort of chiptune sound. That's well and good, and I think what I'm going to do is I'm going to make it a little bit less. Yeah, that should be good. And then now what I can do is, let's go to, where did I have it? It was move. I should be able to insert another thing into here, but first I need to define a new function. That function will be named play. Play x for the pitch equals pulse becomes 25, pitch becomes X. And then if I were to, just to show it off, if I were to do play 6, play 13, and there you go. So now, it doesn't matter. This is such a simple thing. I can do a very similar construction to what I did over here, except instead of picking points, I'm going to be picking notes, essentially. Let's do 0, 3, 6, no, 0, 4, 8, 12. And now that I've added this to the move function, it will get called whenever I hit these buttons. So if I save, oh, oops. hang on. It's reading it as part of the piecewise expression. So I just need to take this code and copy it over, and now that should work. No, huh? Okay. I think the best way to do this... This is a little bit more janky, but it's fine. I can add it down. I can add it over here. This is the one that's facing up. Yeah, this works perfectly. 12. And then 8. And then 0. Save that. You notice how that sounds a little weird? That's because this should actually be 7. Funny way of how the scale works out. Now we just need to add an exit condition and we're done. And here's the thing. I could get so much more complicated with this, but I am content with just doing this and then calling it good. Let's go ahead and add a new thing to the control panel for game over. Have it start at 0, spanning from 0 to 1, step of 1. This will be the variable, as you might guess, that determines whether the game is over or not. And what I also want to do is let's add a variable called noclip, just for the sake of convenience, kind of like the edit mode. It's not required, but it's nice to have. And let's implement those real quick. Noclip should be super easy to implement. I just need to find move, and I think the way that I want to do this, minus noclip, is less than or equal to 0. So right now, greater than or equal to, pardon me. And then while noclip is equal to 1, I can pass through walls. Just a cute little thing. Okay, now we implement game over. So this is another reason why the driver function can be helpful. So let's go to the grid, and we can define another thing. Let's call it goal equals, let's drag this around to a point so it's easier to spot. 1, 3. Make it undraggable, make it green. It's going to be invisible, but it's, you know, it's cute. There's a polygon at with g equals goal. And then the same logic from before. I should have just made a function that draws a square, frankly, because I've been using this code so much. And then let's go to edit mode real fast. Why is this not draggable all of a sudden? Okay. I think it's because it's inside of... Yeah, it's because it's inside of a piecewise, I think. It's making it not like it. Yeah, I can work with it. 0, and then 3, 4. And then 4, 3, 2. That still works. Let's take it out of edit mode. Let's save our progress. We're almost there. The last thing that I need to do is I need to check whether or not we're within the goal. And if it is, then we change game over. And the best way to do this is, because we want the game over state to be persistent after, we want the game over state to be persistent. And then it should be like this. And then let me grab the logic from, where are you? This logic right here. With g equals goal. Oh, right. It's not p. It is frog. Frog, frog. Let's save our progress. Let's turn off Fulbright mode, and let's try and work through the maze. And just like that, game over has been set to 1. So what happens now? Let me reload the page so that everything resets. I just saved, so obviously I'm not going to lose any work. The thing that I did over here is when it got to green, or when it reached the end, everything turns green, and some text appeared that said complete. So how do we do that? Text is surprisingly finicky in Desmos, but what I can do is let's define a point at that is I guess 6.5? Just eyeballing it, that seems right. Make it green, make the point itself invisible, add a label of complete. Make it super big, and then bring it down a little bit. And obviously this is going to be hidden while game over is not true. So let's add that real fast. Equals 1, colon. Game over is true right now, but if I go over and set it to 0, it disappears. And then finally, we're almost done. We are almost done. The last thing that I need to do is I need to make a new color. Grid, or like C grid. equals game over equals 0 equals, yeah, let's do it with 0 and then 1. If it's equal to 0, then the color is just black. Otherwise, the color is... Crap, I had this color written down. Hang on, give me a second to utilize the almighty snipping tool to bail me out here. 56, 140, 70. There we go. Back to adventure. And then just to check, if we set game over to be equal to 1, it changes to green. So now all we need to do is for these polygons, choose this new color secret. And now that should be good. That's everything that I wanted to implement. It's a different maze pattern than the other one. This maze pattern was a lot more intricate. But I mean, hey, if you want to make something cool with this, or if you want to make like another design based on this, or another game even, you are more than welcome to. I have a link to my Discord server in, I think, in the channel info. If not, I'll put a link in the description or something. So if you want to DM me like something cool that you've made in Desmos that was inspired by this, feel free. I'd love to see it. But now let's do a final test. We have the sound on, drivers running. Fulbright is off. Everything is off. And let's play it. And there we go. Depending on if people like this, I'm definitely considering making this a full series. Maybe I try and make different types of games in Desmos. It might drive me crazy, but we'll see. But for the time being, that's all I got for now. Thanks so much for watching, y'all.